Welcome to Unit 3 on two-variable statistics. This is Lesson 6, Residuals. Our learning goal today is to examine how close data is to linear models. We have one learning target for this lesson, and that learning target is for you to feel comfortable saying you can plot and calculate residuals for a data set and use the information to judge whether a linear model is a good fit. We have one glossary term, and that is residual, the difference between the y value for a point in a scatter plot and the value predicted by a linear model. The lengths of the dashed lines in the figures are the residuals for each data point. Our first practice problem for Lesson 6. Han creates a scatter plot that displays the relationship between the number of items sold X and the total revenue Y in dollars. Han creates a line of best fit and finds that the residual for the point 12, 1000 is 75. The point 13, 930 has a residual of negative 40. Interpret the meaning of negative 40 in the context of the problem. So the important points here is that we're looking for the negative 40 for the point 13, 930. We know that the number of items sold is X and the total revenue is Y. When we have a residual, we are talking about the difference between the estimated value at that value of X and the actual result. So a residual of negative 40 means the result is 40 below the prediction. In this case, we're talking about the predicted total revenue. So in context, this means the actual revenue of $930 when selling 13 items is $40 below the predicted revenue of $970 when selling 13 items. So anytime you see a negative residual, that means your actual result is lower than your predicted result. If you have a positive residual, then your actual result is above the predicted value. If you have any questions about how to solve this practice problem, Please use class time to ask for further clarification before we move forward. Our next practice problem, the line of best fit for a data set is y equals 1.1 times x plus 3.4. Find the residual for each of the coordinate pairs x, y. So first thing we need to understand is that your residual equals the actual result minus the prediction. So what we need to do for each of these is calculate the predicted value and then subtract it from the actual value that's given in parentheses. So for number 1, we're going to have y equals 1.1 times x, which is 5, plus 3.4. 1.1 times 5 is 5.5, and 5.5 plus 3.4 is 8.9. So to find the residual, we're going to take the actual result, which was 8.8, and we're going to subtract the predicted result that we just calculated, 8.9, and we find out that the residual is negative 0.1. Number 2, we're going to do the same thing. Y equals 1.1 times x, which is 2.5, plus 3.4. 1.1 times 2.5 is 2.75. And when we add 3.4, we get 6.15. Our residual is going to be the actual value that they give us, 5.95, minus the predicted value that we just calculated, 6.15, and our answer is negative 0.2. Number 3, same process. Y equals 1.1 times x, which is 0, plus 3.4. 1.1 times 0 is 0, so we just have 3.4. The residual is the actual value that they give us, 3.72, minus the predicted value that we just calculated, 3.4, and that's going to give us a residual of 0.32. Number 4. Y equals 1.1 times x, which is 1.5, plus 3.4. 1.1 times 1.5 equals 1.65, plus 3.4 equals 5.05. The residual will be the actual value that they gave us, 5.05, minus the predicted value that we just calculated, which was also 5.05. So we have no residual because the actual value and the predicted value matched. Number 5. Y equals 1.1 times x, which is negative 3, plus 3.4. 1.1 times negative 3 is negative 3.3, and negative 3.3 plus 3.4 is 0.1. The residual will be the actual value that they gave us, which was 0, minus the predicted value that we just calculated, 0.1, and that gives us a residual of negative 0.1. And finally, number 6, y equals 1.1 times x, which is negative 5, plus 3.4. 1.1 times negative 5 is negative 5.5. Negative 5.5 plus 3.4 is negative 2.1. The residual will be the actual value, negative 4.86, minus the value that we just calculated, negative 2.1. If you subtract a negative, you add, and negative 4.86 plus 2.1 gives us a residual of negative 2.76. If you have any questions about how to calculate residuals when you are given a point and a line of best fit, please use class time to ask for further clarification before we move forward. Our next practice problem, plots of the residuals for 4 different models of the same data set are displayed. Which of the following represents the plot of the residuals from a model that fits its data best? So what we're talking about is if a model fits its data well, residuals should be evenly spaced above and below the line. Some of your residuals should be above, some of your residuals should be below, but you should overall have a nice distribution that looks even above and below. In a picture, this looks like a flat brick around the x-axis. So what I want to do is take a look at our distributions. A's distribution, if I drew it like a brick, is going to look sloped down. That's not what we're looking for. C, if I draw a brick around it or a rectangle around it, it is flat, but this brick is basically from the x-axis down. And for D, if I were to draw this brick or rectangle, while it is flat, the whole brick is up above the x-axis. What we want is this flat brick evenly spaced around the x-axis. So that means B is the model of the residuals that we're looking for when they fit the data the best. If you have any questions about how to answer a practice problem such as this, please use class time to ask for further clarification before we move forward. Our last practice problem, a local car salesperson created a scatter plot to display the relationship between a car's sales price in dollars Y and the age of the car in years X. The scatter plot and the line of best fit are displayed in the graph. The car salesperson looks at the residuals for the car sales. So what we want to make sure that we keep straight is that car's sales price in dollars is Y, and we can see that on the label for the y-axis. The age of the car in years is X, and we can see that on the label for the x-axis. So number one, for a car that is 4 years old, does the salesperson sell above or below her average selling price? Explain your reasoning. So what we want to do is go over to 4 years on the x-axis and then go up and find the point for the actual sale and the line that displays the relationship for the average selling price. We can see that this point is below the line for the average. So the price is below the average selling price because the point is below the line of best fit and has a negative residual. Next, we can look at number 2. For a car that is 12 years old, does the salesperson sell above or below her average selling price? Explain your reasoning. So we go over to 12 years, and we see that we need to go up to the actual sales price. So for number 2, the price is above the average selling price, because the point is above the line of best fit and has a positive residual. If you have any questions about how to solve any of these practice problems or about residuals in general, please use class time to ask for further clarification before we move forward into Lesson 7.